Manufacturing of sponge iron is an energy-intensive process. Significant amount of kiln gas is generated in the process, which is let out into the atmosphere, leading to a substantial energy loss. Iron ore, coal and dolomite forms the raw material input for the rotary kiln. Inside the rotary kiln, stage-wise reduction of iron ore to metallic iron takes place. About 6,000 normal cubic meter of kiln gases at an elevated temperature of 850 degrees Celsius to 950 degrees Celsius are generated per ton of sponge iron produced. Under conventional practice, these gases are cooled down to a temperature below 200 degrees Celsius with the help of a forced draft cooler and later passed through an electrostatic precipitator for complete elimination of dust particles before letting it out through the chimney. In the process, not only considerable amount of sensible heat is wasted, but also extra energy is being used for the cooling of gases. The total thermal energy input for a rotary kiln is about 22.5 gigajoule per ton of sponge iron produced, out of which about 8 to 9 gigajoule of energy is carried out by the kiln off gases. This thermal energy available in the waste gas can be reutilized by any one of the following options. As a part of an energy efficiency innovation, a separate rotary kiln is fitted at the feed end of the main kiln. As a result, iron ore passes through the preheating kiln instead of the main kiln. The preheating kiln is fitted in the waste gas path. The position is between the main kiln and the dust settling chamber. As the iron ore moves from the feed end to the discharge end, the gases from the main kiln pass in the opposite direction through the preheating kiln, transferring its sensible heat to iron ore in the preheating kiln. Hence, while leaving the preheating kiln, the temperature of the iron ore rises to above 650 degrees Celsius. Therefore, nearly the whole of the main kiln can be used for the reduction of iron ore. The preheating kiln technology leads to effective utilization of energy which is otherwise waste, increase in productivity by up to 20%, reduction in specific fuel consumption by 10 to 15%.
There is a need to improve the quality of raw material, the technology, and the incorporation of latest technological developments like preheating of the raw materials, efficient use of the sensible heat of flue gases to produce the power. That way you can increase the energy efficiency of your mother equipment, that is a rotary kiln.
The installation of the preheating kiln for a 100 TPD DRI plant will lead to saving of 10 to 15% in specific fuel consumption, implying a saving of 2,400 to 2,600 tons of oil equivalent of energy, a monetary saving of rupees 330 to 350 lakhs, and GHG emission reduction of 10,000 to 11,000 tons of carbon dioxide emission annually. The cost to set up a preheating kiln for a 100 TPD DRI plant is about 4.5 crore rupees. After taking into account cost of operation and maintenance of the system, the investment can be recovered in about 1.5 years. The DRI process is very sensitive to the pressure and temperature in the kiln. The operating conditions from the waste gas induced draft fan up to the cooler discharge point should be properly maintained for ensuring consistency in quality and quantity of the SI produced. Introduction of the new equipment has to be made carefully without affecting the basic operating conditions. The technology of preheating kiln for raw material preheating is an important breakthrough in the sponge iron industry. If implemented in 100 units, the technology can lead to a saving of 2,40,000 tons of oil equivalent of energy and 1 million tons of GHG emissions annually.